Earth Science, Sedimentary Rocks. Sedimentary rocks cover 2/3 of Earth's surface, and they're the most common rock that we see. They're recycled rock, reworked by forces at Earth's surface. Forces of water, ice, and wind, and all over great expanses of time. Sedimentary rocks help reveal Earth's history. Take a walk on a beach or the banks of a flowing river. Look at the sand grains or the pebbles next to the water. Then look up to the rock material surrounding the beach or the river. Do the sand or pebbles resemble the surrounding rock? The beach sand is broken down rock material. The sand was once rock, and the rock is now wearing away to become sand. Recycling in action. Sedimentary rocks are formed at Earth's surface from the cementation and compaction of sediment. Rock fragments, minerals, shells, bones, and even organic material. They can also form through the precipitation of minerals from water solutions. These two different ways of formation divide sedimentary rocks into two groups. Sedimentary rocks made from compacted or cemented debris are called clastic, and sedimentary rocks made from minerals that precipitated directly from surface fluids are called chemical. Let's talk about the formation of clastic sedimentary rocks. Clastic rocks form in a long process with 4 stages: weathering, erosion, deposition, and sedimentation. Weathering is the disintegration or decomposition of rock at or near Earth's surface. There are 2 types of weathering, mechanical and chemical. Mechanical weathering physically breaks rocks into smaller and smaller pieces. For example, the freezing and thawing of ice can widen small cracks in a rock, slowly breaking the rock apart. And plant growth, like this tree root, can also break rock apart. For chemical weathering, it's the reaction with water that decomposes the rock. Chemical weathering eats away at the rock's surface, making it easier to erode. And this makes it easier for rock to succumb to mechanical weathering. The primary agent for both mechanical and chemical weathering is water. Water as a fluid, a frozen solid, and as water vapor in the air. Because liquid water and water vapor are everywhere, chemical weathering actually produces more sediment than mechanical weathering. Erosion is the removal and transportation of weathered rock particles. Running water is the dominant agent of erosion. During transportation, sediment particles collide with one another and break, decreasing their size and rounding off their edges. Looking at the size and shape of sediment particles gives a clue to how far the rock or sediment traveled. Well-rounded grains traveled farther than angular grains. When transportation stops, deposition and sedimentation begin. Deposition is when eroded particles come to rest. Sediments are deposited layer upon horizontal layer, with each new top layer younger than the layers beneath it. This layering is an important characteristic of sedimentary rock deposits. Another characteristic is sorting. Large sediment particles require a lot of energy to transport them. For example, a strong water current. As the flowing water slows down, energy decreases and sediments are deposited. As deposited sediment accumulates, it begins to change into sedimentary rock, the process of sedimentation. Transformation from sediments to sedimentary rock occurs in 2 ways: compaction and cementation. As sediment layers accumulate, the weight of overlying layers squeezes out water from the open pore spaces between the sediment particles. The next step is cementation. This pore water often contains dissolved compounds, such as silica, calcium carbonate, and iron oxide. And as these compounds precipitate, they fill the open pore spaces with mineral matter, which glues the particles together. This process is cementation. Silica cement is very durable and produces some of the hardest and most resistant sedimentary rocks. When iron oxide acts as a cementing agent, it produces the red or orange stain we see in these sedimentary rocks. Onward!